One point before we begin. This meeting is being recorded, so maybe it's time to reconsider if you have a strong opinion about that. Hope nobody objects.
Okay, Ayrton, you can hear me okay and everything looks fine? Yeah? Ayrton, you can hear me? Could you hear me there? Yeah? Yes. Yeah? Okay.
Yes.
Okay. So as Ayrton said, I'm a technical author at Canonical, and in this presentation I'm going to be talking about video and documentation. And Ayrton will provide a link to the repository where the source of the slides are located, and also there's a website where you can look at the slides. So the purpose of this presentation isn't to convince anyone that we have to use video in documentation, or that we should use more video in our documentation. One thing I want to do is try to talk about some tools that might make it easier to use video in documentation. And before that, I want to talk about what specifically video might be able to communicate that is difficult to communicate in text. And as a part of that, we're also going to talk about, some cases where we definitely shouldn't use video because text is a suitable alternative. So here we have this beautiful nature scene, probably shot by a drone, and we've got a stream and a nice kind of waterfall and some wet rocks and some moss, and the moss looks slippy, and we can imagine that there's some splashing noises and things like that. So this is a really beautiful scene. And video footage like this really angers me, because I think, couldn't this all just be plain text? And, that's a bad example. There's more obvious examples of this. On this screen, we have a video which shows some terminal commands. And the first command, we create a directory, then we change into that directory, and we pipe a short script into a Python file, and then we run the script and we generate an output. And everything in this video is text. And we could imagine quite easily rendering this as just a series of lines of text in documentation. And it would essentially communicate the same information. And this is something very different to the video we saw before, where we had video communicating a lot of things that would be difficult to communicate well or consistently in text, because video has certain capabilities, such as the fact that it's multimodal. So we can communicate with text in a video, but we can also communicate with visuals, and we can communicate with audio, and we can make connections between those different things. So it allows for certain complexities that are very difficult to recreate in plain text. Now here's an example that's a little bit more complex. So we're still talking about text, essentially, but this is a much richer CLI interface. So we have text suggestions, we have dynamic suggestions that are rendered in color depending on what we enter. We've got menus that we can move between, and we've got, again, dynamic warning text being generated depending on where we are in the menu. And then when we are finished, it gives us a success message, and it tells us some additional commands that we might want to run afterwards. So this is an example of a rich text interface, but other organizations like Charm, for example, are committed to giving people tools to make even more beautiful command line interfaces. And here we have an example of a very nice progress bar. And this is something that we are talking a lot about at Canonical at the moment. We're not necessarily talking about strictly the aesthetics of command line interfaces, but we are talking about how they're designed and the design affordances that are in command line interfaces to make them more pleasant and efficient to interact with. So this type of CLI is a little different to the early example that we saw, or the early example of a terminal where we're running commands. Here we've got, things like spinners, which communicate some information to the user. We've got progress bars. And if we're putting in the effort to make a beautiful terminal experience like this, perhaps there's an argument that we should be showing a potential user what this interaction looks like through something like a video, rather than simply converting this into lines of plain text in our text documentation. When I started thinking about video, when I began working as a technical author at Canonical, I wanted to find some examples of where we were using video already. And there was one set of documentation I was working on for ADSYS, which is just a tool for managing for helping system administrators manage Ubuntu machines in organizational environments. And there was one tutorial for this set of documentation, and the tutorial was essentially a video. So there was a very brief introduction to the video, and then there was the video itself. And if I played this video just briefly and we have a quick look at it, essentially the video consists of text. So in this section here, we're largely seeing plain text rendered in a terminal. So again, this is, I think, somewhat of a simple example of a case where we should probably be thinking about converting this tutorial into plain text. Because if we keep it as a video, we're essentially showing people text in a form that's going to have poor accessibility. It's going to have a potentially a larger file size if we're storing it in a repo. That's not what we're doing here, but we could be thinking about doing that. So we're using a very powerful medium, the medium of video, to communicate information that can very easily be rendered in text. Then I found other cases which reminded me of my previous career, which was as a scientist. So for about 10 years, I worked as a scientist, and most of the written material I was producing was in the form of scientific papers. And this was one of the last scientific papers that I produced. And it was actually, rather than a scientific paper, it was more of a paper about technology focused on software that I made for teaching a certain concept related to science. But the point I want to make here is that when you're writing a scientific paper, you always have to write an abstract. And there are different ways of thinking about an abstract. Usually it's described as essentially a kind of a summary of the paper, which highlights the main points. You can think of it as an entry point to the paper. But I like to think of it as a kind of a tiny invitation. Because when you're a scientist, you're under massive pressure to constantly be keeping up with an ever-increasing amount of literature. And what you end up doing is you end up scanning, hundreds of papers, it could be over the course of a few weeks, scanning them quickly. And what you do is you read the abstract, and you determine, do I want to go further with this paper? Is this worth my time? Because these things are usually really difficult to read. Most scientists, when they're writing, they're not concerned with readability or things like user experience. They're concerned with communicating the technical details as factually and as completely as possible. So it's really going to be a lot of work to read, let's say, a paper like this. And the abstract is an invitation which says, I think there's some pretty interesting stuff in this paper, and here's what we did in this paper, and here's what we achieved. And if you read it, this is what you can expect. And around the time I was finishing up in my science career, these graphical abstracts became more common, which were essentially graphical versions of the information that was communicated in the abstract. And we were increasingly encouraged to include these at the start of our papers in order to summarize in a compelling way the technical content that was going to be in the article. So at the same time, there was also an increased emphasis on potentially including video abstracts in our scientific papers for the same reason. So some of the examples I saw when I was looking at Canonical's documentation reminded me of this kind of abstract. They weren't necessarily a replacement or a simplification of the scientific content. They were something that accompanied it in order to act as a kind of invitation. So this documentation here is for LexD, which is a software for creating and managing containers. And there's a video in this landing page. So this is a how-to section. And in this how-to section, there's a landing page which links to specific how-to guides. And we also have this video. And this video is about 3 minutes long. And it starts off by installing the LexD software. And we see that, this is going to take a certain amount of time. It's going to take a certain amount of time to install the software and set it up and configure it. And if I just fast forward a little bit, a lot of things happen here. So the person who's using this is initializing LexD. They're pulling some images from a remote source. They're creating containers. They're launching the containers. And all of this happens in about 3 minutes. So this is essentially a kind of complete walkthrough or a snapshot of the suite of functionality that this software has, going from installation up until usage and deployment. And this video is created in a very specific way. So it's written down here, recorded with Askinema. And Askinema is a specific software for making videos, which has certain properties that are desirable to someone who's working on technical documentation. And I'll talk about that in a little bit more detail later on. So there's something really nice to me about this. So this isn't a replacement for the documentation. This is not a replacement for the tutorials and the how-to guides in the LexD documentation. It's something that appears on the landing page. It's not something, when we're looking at the documentation, it's not something we necessarily need to scroll through. It's all in a contained space within the documentation page, and we can consume it passively. So maybe we're not convinced that we need LexD, or maybe I'm looking at this on my phone and I don't have access to a computer to spend 20 minutes following a tutorial. This gives me in a contained space a full preview of what I expect to happen if I download and use this software. And it's in the landing page, and it acts as a nice preview for the rest of the documentation. So it's something that can supplement the documentation rather than replace it. And there's something else that I like about the previous example, which is that it communicates, in some sense, the performance of the software. So there are certain commands that are run which take a certain amount of time. So pulling an image from a remote source might take a certain amount of time, and we see how long that takes. And we can imagine that the software engineers who are involved in building this product have thought about performance and want it to be fast and want people to have an efficient experience using the software. And that's something that's really difficult to capture in text. And just to make this example a little bit more clear, here's an example I like that I recorded. On the left, we have the text editor Vim, and on the right, we have the text editor VS Code. And what I'm essentially doing is, on the right, I'm opening VS Code once, and on the left, I'm opening Vim about 7 times. So I can open Vim about 7 times in the same amount of time I can open VS Code. And these are both wonderful editors. I use them both for different reasons. But when I have conversations with people about VS Code, when they use VS Code, I'll say, things like Vim are much faster. And there's reasons for that. Vim, in its vanilla state, doesn't attempt to achieve as much as VS Code. VS Code has a lot more features built in, which make it a little bit slower. But people who use VS Code will say, well, I don't notice the speed difference. And we could communicate the speed difference with bar charts or by talking about percentage differences, but it's difficult to feel the speed difference unless you actually compare the applications, or unless someone shows you video comparing the performance of the applications. So I think that video sometimes can be really useful at communicating some of these more intangible things that are difficult to communicate in text, or maybe are difficult to communicate convincingly in text. So if you say, for example, we've engineered this amazing piece of software, thanks for visiting our documentation. When you use our software, you can expect it to be blazingly fast. That's not necessarily convincing. It's not persuasive, because anyone can say that about their software. You still have to show it, I think, sometimes to be convincing. So I think this is one example, I think, where video can be quite useful, is demonstrating performance. And performance in software is really, really important. Slow software can be a real killer when it comes to the user experience. This is another example of an ASCII-NUMA video that I just wanted to show. And this is used in a kind of storefront. So this is for the Golang language and compiler. And this is a snap. So snap is just a package manager that we can use to install certain packages on Ubuntu. And we have a video here. And again, it's very tight. We don't have to scroll down the page, look at all the content. And what the video does is it goes through installing the package, running a simple program, and seeing the output. And what I like about this is it's a storefront, right? So we can see the Golang branding. We can see who maintains the package. There's a drop-down menu for changing releases, and there's an install button. And all of these things remain in view while someone is watching the video. So because the video doesn't occupy several pages worth of scrolling, we can watch the video, see a preview of how it works, how quickly the commands run, and then we just need to avert our gaze to the side of the screen to see the install button or to see the drop-down menu for changing the release. So I think there's something about we could say the ergonomics of video, which is that people can passively consume something which demonstrates the value of software while also not having to traverse the website that the video is on, and that would otherwise consist of maybe a lot of text. So this example, it basically shows in a very convenient way what the software does, how quickly it does it, and you can make a decision afterwards. Do I want this thing? And if you want it, you click the install button. So it's a really convenient package of components. Now, I've been talking so far about command line interfaces, and I think that's the more difficult argument to make. So when I was introduced, Airtum said that video and documentation is a controversial topic. I agree. But I think it's less controversial when we start talking about graphical user interfaces. And I really like using this graphical user interface as an example, because I made it. I'm not a very good programmer, but I made this very awkwardly a few years ago. And it works okay, and it's useful for demonstrating a very simple graphical user interface. So you can watch me use it here. You can see that there's this, the cursor turns into a hand when I hover over the model. And this suggests to me this is something I can drag, so I can move my mouse and move it around. There's a color wheel, and it turns into a kind of crosshairs. So this suggests to me I'm going to select something. I can change the color. I have a scroll wheel in my mouse. I'm thinking, if I move the scroll wheel, do I zoom in? And yes, it does. Probably what you'd expect if from using other software. And then there's some checkboxes. I can click on these to check them. I can turn it into a wireframe. I can hide the grid. There's arrows going down. This must mean I'm downloading something. These are files for things like 3D printing or for creating game assets. And then there's some other buttons for, changing the model and things like that. So this application is really simple, and it's quite easy to watch someone use it and get a feel for what happens when you take certain actions. So you can see here, if I drag my mouse, you can kind of see the amount of inertia, for example, in the rotation. You can see the effect of how the lighting shines off the model, and you get this real sense of what your interaction will likely result in. Now, we could convert the things I've been showing you into text. So we could say that pan with the right mouse button, rotate with the left mouse click, zoom with a pinch, adjust color with the color picker. You can download 3 different types of 3D model formats. We could imagine, as technical authors, putting a lot of words behind this description. And I think that in this case, it would be very ineffective. I think you could show someone how this works with a video in maybe 15 seconds. But that software that I created is really simple because I'm a really basic programmer. There are far more sophisticated graphical user interfaces out there. And one of the most popular open source projects is Blender, which is a piece of software that does a lot of things very well. So you can use it to create 3D models. You can use it to do digital sculpting with a digital pen. You can use it for 2D animation. You can use it for motion graphics. You can use it for video editing. You can use it for compositing. It's an incredible piece of software that does a lot of different things. And because it does so many things, it naturally has a very complex user interface. And what I find really interesting about this is that the community around Blender tends to produce and consume lots of video documentation. So video tutorials on YouTube, for example, by really popular YouTubers like Blender Guru. And this is a really popular tutorial that he refreshes every few years, where he makes a donut using Blender. And you can just see at a glance here that there's a lot of stuff going on in this interface. So at the top right here, we have a tree of all the different objects that are in the scene. We have here in the center a radial menu. At the bottom, we have this new concept of geometry nodes, which is basically a kind of a way of designing 3D models using kind of flow diagrams, connecting nodes together. So this is really complex. And to learn this skill of using Blender, people often opt for this type of video tutorial where they can see people demonstrate their mastery of the software, like it's a fine craft, and they want to see this master user, Blender Guru, using this tool really well, so that they can start their journey of mastery as well. And the same guy, so Blender Guru, his real name is Andrew Price. He recently presented at the Blender conference, and his presentation was about how to improve Blender's UI. So this is someone, you could argue, who has, I guess, made a living of telling people how to navigate this difficult user interface. But he's aware that the user interface could probably be simpler. And I think there's an important lesson here, which is that I think there's a temptation sometimes to say, well, the problem here isn't producing really good video tutorials. The problem is we need to fix the UI issues, so there's no need for video tutorials. And this is basically another version of the argument that, well-designed software doesn't need any documentation, whether it be written documentation or video documentation. And I think the most pragmatic way to think about this for me is that software is always in this process of iterative development. There is always going to be a point in time, and that point in time can stretch quite long. There's always going to be a point in time where your UI isn't as perfect as you'd like it to be, and during that stretch of time, you might need a video tutorial to help the people who are using the software when it's in that state. So yes, I think the ideal situation is that you have a very complex piece of software that has a really simple user interface that people can use very intuitively. But the reality is that process takes time, and there's going to be users of the software who suffer during that time if they don't have guidance on how to use the software. So Blender is, I think, a really good example of an amazing piece of software that has a huge community, and many people in that community have become professional graphic artists, professional environment designers in game studios by learning Blender, at least at the start, through these kinds of video tutorials. So I think there's a way of looking at this story of saying Blender is a very popular piece of software. A lot of people who want to learn how to use Blender use video tutorials. So I think there's a way of looking at this as being an example of video tutorials being successful rather than this use of video tutorials is evidence of a poor UI. I think there's a story here from a documentation perspective, which says that video documentation has been a success for Blender. Back to command line interface examples. I was just talking about graphical user interfaces and how they can be really complex and how this can make them suitable for description using video. But command line interfaces can also be really complex. And the kind of complexity that I encountered initially when I started working at Canonical was these kinds of software tools that allow developers to switch environments and to create new environments and to move between environments and to exchange information between environments. So a piece of software that I work on a lot is Ubuntu for Windows, or Ubuntu that runs on this software called the Windows subsystem for Linux. And this is something that allows you to run a Linux environment on Windows. And if we look at this text here at the top, it says PS. This is a prompt. So PS is PowerShell. That's a shell that runs on Windows. And then we have a funny looking path, if you're from a Linux background, which has backward slashes instead of forward slashes. So this is a Windows path. So we're in a Windows machine. This is a physical Windows machine. And what I'm doing is I'm running an Ubuntu executable. And this is going to create an instance of Ubuntu as a kind of virtual machine that I can then enter inside my Windows machine. So if we move down a step, we see the prompt has changed. So we've gone from a PowerShell prompt on Windows to now me in a Ubuntu WSL environment. And then when I'm in that environment, I can do other things, like I can SSH into a server. And now the prompt says I'm somewhere else. Now I'm in a server. It could be a remote server in a different part of the house. And then I can use a tool like Multipass. So Multipass is a tool Canonical has developed for creating virtual machines and also miniature cloud environments that you can create quite easily. And inside that server, we can use Multipass to create a virtual machine. And then we can exit out of the virtual machine, exit out of the server, exit out of the Windows subsystem for Linux, and then we're back in our Windows machine. And when I first encountered these kinds of examples, this is a bit of a contrived example, I admit, but when I first encountered these kinds of examples, I found them bewildering. I found myself thinking, where am I while all these commands are running? Where am I now? I've switched context multiple times. And people at Canonical who had used some videos of terminal sequences said to me that they found video very effective for certain users when communicating this type of sequence of commands where people are switching between different contexts. So in this case, we're moving between Windows, WSL instances, servers, VMs, and the temptation, I think, especially when we're changing environments in documentation, is to put maybe each change of environment into a new code block. Because here, every time we change environment, we're signifying the change with a new prompt. And these prompts, they're ugly. You know, we've got these arrow symbols, we've got carrots, we've got dollar signs. Typically, when we document terminal commands, we want to avoid including this kind of noise in prompts. So we might want to say something like run ubuntu.exe, and then now you're in a WSL environment, and in a separate code block, now you run SSH Shane at Ubuntu server. And you end up with a kind of fragmented series of separate, distinct code blocks. But for the user, they're always operating in the same terminal. So whether they're in a remote server, or whether they're in the Windows subsystem for Linux, or whether they're in the cloud, they're always operating in that same visual container of the terminal that they're using. And some of the people I talked about who were documenting this type of user experience were saying that they found video a really effective way of communicating to users that flow of moving between these different contexts. And this is Another simple example from me and the kind of stuff I do in my spare time. So on the left here, we have a bash script, and on the right, we have some panels, and they're showing different things. So at the bottom here, we have the user interface, and this is created by the source code on the left. And we're going to see in a second that the user gets a menu of options, and they're going to add a new task. So this is a to-do app. And what you're going to see right above after this is done is that the task is added to a kind of database. But another thing that happened over on the right is that we also created a backup. So each time we add a new task, we're also creating a backup. So in this video, we're capturing a lot of different things. We're capturing the source code, the interface that the source code creates, the database that's populated through interactions with the interface, and then the backup files that are generated as the database is updated. And of course, this is, again, one of my crude personal examples, but of course, there are many other examples out there of these interconnections between the different contexts that a programmer or user operates in. And I think a video here, accompanied with a suitable explanation, very compellingly shows the different things that software, the different, I guess, causes and effects that we have happening in software when we run it. And this can be a very effective way of explaining what software does by showing these things all at once in a holistic manner, an interconnected way, in the form of a video. If we don't do this in a video, we end up flattening everything into a kind of linear sequence of text in a page that we might have to scroll down for quite a long time. So in this case, what I wanted to highlight was that through video, we can show multiple contexts at once. And some of those things can be causes and some of those things can be effects. And we can try to create connections between them. So at Canonical at the moment, we have a style guide. And after I did my initial research into video, I thought we needed to add something about video to the style guide. And this is what I came up with the help of a colleague. And basically what it says is that, very rarely will a video be an effective replacement for text in documentation. And that goes back to an earlier point I made, which is that, some really effective uses of video aren't replacements. They're something that accompanies the documentation or maybe acts as an entry point. And then I illustrate some points, or I explain some reasons why it's maybe not a good idea to use video. One is that they're challenging to do well. And here I'm thinking of something like using an actual dedicated video editor, something like Kdenlive, something like DaVinci Resolve. These things take some time to learn, and they can be very challenging to master. The video is difficult to maintain. So if you've used a dedicated video editor, and if you've spent 6 months learning how to use it, and you create a beautiful video for your documentation, it's going to be very difficult to update that video in a few years' time. And if you've moved on to a different department or maybe a different company, whoever's left behind almost will certainly not be able to achieve what you achieved using your video editor. And then also there's things like accessibility issues that people listening will be very familiar with. But I also, when I added this to the style guide, I wanted to recognize some things that the people at Canonical were doing that I think were good ideas. And one tool of many tools is highlighted here, which is Askinema. And this is some of the videos we saw earlier from Canonical were created using this specific tool. Now, this tool, just to foreground this a little bit, this tool is something where you basically, it's a command you run in your terminal, and it allows you to record whatever you do next in your terminal. So if you want to illustrate to a user a certain series of commands that produce some outputs, you can record what you do in the terminal using Askinema, and then it will convert it into essentially a source code for your video. And then you can version control that source code. And Askinema also has some other interesting properties, like the fact that the user can copy and paste text from the video, which is a really unique feature. So Aschinema, I think, was used quite effectively in those cases I was talking about as almost like abstracts that would be entry points to documentation. And it also has some design affordances which help solve some of the problems that video traditionally has within documentation. One of those problems is that it's difficult to maintain because, for example, we can't version control it. With Aschinema videos, we can version control. Another issue might be if someone creates a video of someone running terminal commands, then the user can't copy the commands to very quickly put them into their own terminal and try them out. Aschinema solves that problem. So here, I think it's important to stress that video is often challenging to do, especially if you use sophisticated video editors, but there are tools available to make the process easier and also to make them conform to the types of workflow that we might expect in a software development environment. So this was my contribution to the style guide on video, but I felt dissatisfied after, because I just think it's such a rich, interesting topic. I think there's a lot more that video can do. I think there's a lot of things that Aschinema doesn't do. And I think there are some problems it doesn't solve. So I was really, after I wrote this, I really felt like there was more work to do and more thinking to do on this particular topic. So on this grid, I basically have a summary of the kind of tools that I'm going to be briefly talking about. And from left to right, they go from manual to programmatic. So on the far right, we have things that can be automated very easily. On the far left, we have things that are almost completely manual. And then from bottom to top, we have static to dynamic. And by static, I mean, if you use a video editor like Kdenlive, you produce a rendered video in a format like MP4. And you can publish that video, you can send the file to someone, but it's very difficult to manipulate or edit that video. It's essentially a final endpoint for the production process. Aschinema then, interestingly, I have it as something that's a little bit more programmatic than a video editor, but it's still quite manual. Why do I say that? I say that because you still have to record yourself in the terminal. This is something that if someone wants to update the video in 2 years' time, they're probably going to have to record themselves in their terminal. They're probably going to have to download Aschinema and do the recording again. And having done some of these recordings myself, if you make a mistake in your recording, it makes its way into the final output. So this is something that's somewhat manual. And I say the content is dynamic here in the sense that the final video, it has some degree of interactivity. So people can copy and paste the text from an Aschinema video, for example. Now, on the other extreme, we have JavaScript. So it's possible, I've done it, and the lesson here is in what I'm going to say next. I've created interesting looking interactive terminal interfaces using JavaScript that can be embedded in a web page. And I wanted to put one in the slides today, but the terminal that I created in JavaScript a few months ago, I couldn't get it working again because it was too complex how I implemented it. So you can use web native scripting languages to produce really interesting visualizations and terminal interfaces. But that's very demanding on the technical author, for example, who has to do that. VHS is a tool that I haven't talked about yet, and Motion Canvas is a tool that I haven't talked about yet. And I think these are two really interesting options to compare and contrast with ASCII Cinema, and that's what I'm going to talk about in the next section. But here, looking at this grid, the point I want to get across is that there are options when it comes to using video in documentation. You don't necessarily have to use a video editor. If you want to, you don't have to script the video with a programming language or with a markup, with a configuration language. You don't have to do that either. There are some things that are in between. There are some things where you can use a command to record what you're doing in the terminal. There are other things where you can create a video using something that isn't as powerful and complex as a scripting language, but something that resembles more like YAML or something like that. So there are options, and I think as people work in documentation, we should be aware of the options, where they differ, and what they can do for us in documentation. So just to quickly illustrate something I've mentioned a few times, but haven't actually demonstrated, this is an embedded Askinema video. And I can pause it here, and I can take some text, and I can copy it just like I would any other text, and I can paste it below. So I can take text from this video, and I can paste it into a terminal and run it in my computer. And something that we might want from a tool like this is we might want to be able to version control the video. So in this case, we might want to generate some source code that we can then put in our repository to ensure that we can version control it just like we do our code. But this is what the source code of an Askinema video looks like. It's actually really difficult to read. And if we look at it very closely, so if I highlight this section, and if you read from top down, you can see hello world is embedded in this array or set of arrays. So this source code is generated and it can be version controlled, but it's not something that's readable or editable, or at least not easily readable or editable. VHS is another tool created by an organization called Charm, and its source code is much more readable. So if you look at this source code here, it's in a file called with a tape extension, and it says type this command, wait for a certain amount of time, enter the command, which means you run the command, and then type something else, and so on and so forth. So this is much more readable, but also it means it's much more potentially maintainable, because this is something that we can actually edit and update these set of commands if we want to when we come back to revise our CLI in a few years. And this is something also that can be automated. So VHS has GitHub Actions available in the marketplace that can be used to incorporate VHS into CI pipelines. And we're currently working at Canonical on an authentication, a cloud authentication software called authd. And this allows a user to, when they're logging into their computer, they can authenticate with a cloud service like Entra ID, for example. And what we can do with VHS is we can generate something called a golden file. So what we have here is, this is essentially a video, but it's divided into scenes. So the first scene here is the QR code, and the second scene below the horizontal bar is success after someone authenticates. And VHS can also generate these plain text files, which are essentially a sequence of scenes from your video. And what these can do then is we can create the sequence of scenes that we would expect if our software works correctly. And then the next time the software changes or the source code changes for the software, we can recreate the sequence. And then we can diff between the golden file, which is when everything works correctly, and the new file, which results after we change the source code. And then we can run a diff between these two different things. And if there's a difference, then there might be some type of error that was introduced in our source code. And a video is generated as a part of this process. And the programmer can then go and look at the video and see maybe what went wrong in that sequence of events. So this is a really powerful piece of software. Motion Canvas is something that can achieve a lot more than generate videos of terminal commands. So this is something that gives you the power of a full programming language, either in the form of JavaScript or TypeScript. And I have an example here of code for generating video at the bottom. And the code at the bottom here helped generate the following video. And I won't go into this in detail, but this video shows a debugging process on the left, so stepping through the process of debugging some code. And what we're debugging is a for loop, which is shown on the right in the source code. And the green circle is basically moving up and down as we move through the for loop. And in this video, we also have the index that's generated in the for loop and the sum. So the for loop is a part of a function that calculates the sum of a set of numbers. And ultimately, the circle turns red, and we highlight what goes wrong in the code. We generate an error, and it's because there's an off by one error in the for loop. So this is a video which, again, takes advantage of the video format by connecting different pieces of context. So we have the debugging process, we have the source code, and then also we have the values that are being generated by the code, such as the sum. Now, Without video here, we would tend to flatten this description out into something more linear. So the text-based version of this consists of 10 steps. So this shows step 9 here, and we can see there's a lot of repeated information. And I think this kind of documentation can be very difficult for someone to persist with and follow. It contains a lot of the same steps, and it can be quite cumbersome to follow these steps in your own computer. A quick mention then goes to Manum. Manum was created before Motion Canvas, and it was developed by Tree Blue One Brown, who's a very famous YouTuber who makes explanation videos about mathematics. And it's a Python library, so it's probably more easy for people to write who are not, especially those who are not familiar with JavaScript. And we can use Manum to create videos like this. So Manum wasn't created for software development or explaining software development concepts, but we can do similar things with it. So here we generate an animation of a terminal, and on the right, what I'm trying to do here is show that we can, with the software, we can show the commands, and then we can try to illustrate what's happening in some type of simple way using shapes. So here we're generating a virtual machine inside of our physical machine, and we can try to illustrate that using a set of nested boxes. So just to finish up, at Canonical, the foundation of our documentation is diataxis, and this identifies certain core types of documentation, like tutorials, how-to guides, explanations, and references. And we try to identify the content that fits into these types, and we try to ensure that we don't have these types of content mixing together in our documentation. And something that I'm still thinking about is, where does video fit into this framework? Or is this framework suitable for video? And the question I arrived at initially, and this is something I haven't thought enough about yet, is, would you want to watch a reference video? So a reference is something that just consists of factual information. We might imagine, a table of software and the amount of storage that they take up, or something like that. So would we want to watch a reference video? Probably not, because video excels at different things. And what I've tried to say in this presentation is that it can be very good at demonstrating mastery, such as someone who's a really effective user at Blender and who wants to show people how they utilize that skill. And I also think it's really good at integration. So I said at the start, video is multimodal. It can combine sights and sounds. It can simultaneously show multiple contexts and how they interconnect. And this is something I don't think that making a reference video, just as the simplest example, I don't think a reference video would fully maximize the potential of a video. But this is something I need to think about, and I think other people need to think about it too. And just to finish, I have an example of another video, and this is mostly text. So this is just all we're looking at here is text, but it's a great video. This is the Primogen. He's a YouTuber. He's a former software engineer with Netflix, and he's a very popular YouTuber. And he always streams working in the terminal, working with Vim. And what we're seeing on the screen here is him basically doing a master class in using Vim very fast. And what we see is, we see him, we see how he reacts as he's going through this process. On the bottom right, we see him using his keyboard incredibly quickly. At the top right, we have a timer which shows how quickly he's moving through this. So this is something it's again primarily text-based, but I think it's something that should be a video, because what it does is it demonstrates mastery, and it also integrates different components. It shows him, his personality, it shows him physically using the keyboard, and it shows what he's actually doing on the computer. So that's it for me. Thanks everyone for listening.
Thank you, Shane.